OAB is a triangle, OPM and APN are straight lines. M is the midpoint of AB, so I know that AM and MB are equal to one another. O to A is vector A. O to B is vector B. I'm told that OP to PM is 3 to 2. And I need to work out the ratio of ON to NB. O to N is here, N to B is here. So I need the ratio of this and this. Well, because I know that ONB is a straight line, and I know it's a straight line because OAB is a triangle. So because I know that's a straight line, I could say that ON equals some fraction of OB. This is some fraction of this, because I know it's a straight line. If I can then work out what that fraction is, then that's going to help tell me what the ratio is. I can go one step further and say, because I know that OB is vector B. Right, whilst continuing on a similar theme, because APN is a straight line as well, I could say that AP is some fraction of AN. We'll come back to that in a moment. Right, in order to solve this problem, I want to consider one journey, one vector in this triangle in two different ways. The vector I'm going to pick, I think, will be O to P. What's that vector there? Well, I know that that is 3/5 of vector O to M. So I can say that O to P equals 3/5 of O to M. Vector O to M, well, that's the same thing as me going from vector O to A and then A to M. Now, A to M, that's half of A to B. And that's hopefully now enough information for me to write this in terms of A and B, in terms of my vectors A and B. Because I know that O to A is vector A, and I know that vector A to B, well, that's the same as going from A to O plus O to B. So that's minus A plus B. Let me just simplify that then. So 3/5 of A minus a half A plus a half B, or 3/5 of half A plus a half B, which is just 3/10 A plus 3/10 B. Let's just remind myself that's OP that I've just worked out here. Let me now consider OP in a different route. The route I'm going to take this time, I'll go O to P. I'll go OP. O to P is equal to O to A plus A to P. Here to here, and then there to there. O to A, I know that that is just A. A to P, well, I know that that is mu times AN. Mu times AN. Now, A to N, that's the same as me going from A to O plus O to N. A to O is minus A. O to N, excuse me, was lambda B. Right, just expanding and simplifying that then. And whilst I'm at it, let me group up those A terms, so factorise that A outside at the front there. So what I have got here is two different ways of me writing the vector O to P. These are the same vector. These two expressions must be equal to one another. In even more detail, the A components of each vector must be equal to one another, and the B components of each vector must be equal to one another. So let's focus on the A components first. I can now say that 1 minus mu is equal to 3 over 10. Therefore, mu is equal to 7 over 10. So what that's saying is that, remember, mu was the fraction of AN that was the vector AP. So it's saying that A to P, this part is 7 parts of the vector. This part was 3 parts of the vector, 7 out of 10. But more importantly, we can use that to help us to answer the question, because I can now compare the B parts. 3/10 has to be equal to mu lambda. And given that I've just worked out mu, I can say that 7/10 lambda is equal to 3/10 times both sides by 10. And I find that lambda is 3/7. Let's now take that and put it back where it came from in the first place. I am saying that ON is 3/7 of the vector B. O to N is 3/7 of the whole vector. O to N is 3 parts. N to B must be 4 parts in order for it to have the fraction 3 to 7. Therefore, the ratio ON to NB is equal to 3 to 4. And that is your answer.